Welcome to The Explainer. Today, we're jumping into one of the most exciting areas in all of AI. We're talking about systems that don't just think in text, but can see, hear, and connect ideas in a way that feels a lot more like us. This is all about multimodal AI.
But before we even get into the tech, just think about this for a second. How are you experiencing the world right now? You're not just using one sense, right? No way. You're combining everything. What you see on the screen, the sound of my voice, maybe even text you're reading. It all comes together to create one complete picture.
You see stuff, you hear stuff, you read stuff, and your brain just effortlessly blends it all together. And that last part, connecting it all, that's the real magic. And that's the core idea driving what's probably the next huge leap for artificial intelligence. So this brings us to what we're actually talking about, multimodal AI. It's about building one single unified system that gets it all, images, audio, text, all at the same time. And the big goal here isn't just to have an AI that can do all these things separately. It's about teaching it to understand the deep, fundamental connections between them, kind of like our own minds do. Okay, so we've covered what it means for AI to see and hear. So here's where we're headed next. We're going to look at the core architecture. Then we'll get into how these models learn to connect things. After that, we'll check out some amazing real-world uses. And finally, we'll tackle what's called the synergy challenge. All right, first up, the blueprint. To really get why these new models are such a big deal, we got to look at how things used to be done. The old way was, well, kind of clunky. It was like a game of telephone. You'd have one model for speech to text, which passed its output to another model for language, which then passed it to another for image generation. It was a chain, and with every single handoff, you'd lose crucial context. The new way, though, is a total game changer. It's one brain, one unified system that sees and hears everything at once. It's way faster, and because nothing gets lost in translation, it's just so much smarter. This unified model is really the key to everything we're about to see. So how does one of these unified models actually work? Well, you can think of it as having three key parts that have to work in perfect harmony. First, you've got the encoders. These are like the AI's eyes and ears, turning pixels and sound waves into a language it can understand. Then you have the connector. This is the universal translator, the bridge that gets all that different data into one common format. And finally, you have the LLM backbone. That's the central brain, doing all the heavy lifting, all the reasoning on this incredibly rich, combined stream of information. That all sounds pretty amazing, right? But how in the world do you actually teach a model to connect a picture of a dog with the actual words photo of a dog? Well, that's where the secret sauce comes in. The primary technique is something called contrastive learning. Basically, you feed the model an insane number of images paired with their text captions. For every single image, the AI is trained to pull its internal representation of that image closer to the right caption and at the same time, push it away from all the wrong ones. It's like a massive high-speed matching game on a cosmic scale. And what comes out of all this training is the magic part. It's something called a shared latent space. You can think of it like a conceptual map inside the AI's mind. And on this map, the idea of a cat, whether it's from seeing a picture of a cat or reading the word cat, they both live in the same virtual neighborhood. This shared map is what unlocks some seriously powerful applications out in the real world. So let's go check those out. So we've got a handle on the how, but now for the really important part, the so what. I mean, how is this technology actually changing things today? Let's take the legal world. These AIs are becoming real analytical partners. Think about it. Instead of just reading a flat transcript, an AI can analyze a witness's tone of voice, their facial cues, and the text all at once to spot inconsistencies. Or it can look at a contract and understand that bolded text carries more weight than regular text. It's about getting the full picture, the whole context, that a human lawyer just naturally picks up on. And the results? They're pretty staggering. We are talking about an 80% reduction in labor costs for certain initial review tasks. That is a massive shift. It frees up incredibly smart, expensive lawyers to focus on strategy and the human side of the law, not just tedious paperwork. And you see a very similar story in engineering. This tech is being used to create what are called digital twins, perfect virtual copies of physical things. In a factory, for example, an AI can listen to a machine's sound, feel its vibrations, and see its heat signature, and then use all that data to predict a failure days or even weeks before it actually happens. And that ability to see the future, so to speak, has huge consequences. We're looking at a potential 25% cut in industrial downtime. Now, that doesn't just save a ton of money, it actually makes our entire supply chains more resilient by heading off those really costly, unexpected shutdowns before they can happen. And then there's science, where multimodal AI is just smashing down data silos and speeding up discovery. I mean, in medicine, a single model can look at a patient's MRI scans, their lab work, their doctor's notes, and their genetic code, all at once, to find these incredibly subtle patterns that humans might miss. It's literally finding the needle in a universe of haystacks.
Okay, so these applications are incredible. I think we can all agree. But the technology is far from perfect. In fact, there's a really big hurdle that researchers are laser focused on right now.
This quote from a new research paper really nails the problem. The challenge isn't just to give an AI a bunch of different skills. It's about making those skills actually work together, to have real synergy. See, it's one thing for an AI to describe an image and also answer a question, but it's a whole other level for its visual understanding to make its reasoning fundamentally better.
And a new test designed to measure this exact kind of synergy shows us just how far we have to go. Get this, the top score for a leading open source model was just 37.5%. That number tells you everything. It shows that even our best models today are more like skilled multitaskers than truly integrated thinkers. There's a lot of work to do.
And of course, as these models get more powerful, we have to walk a pretty fine ethical line. For example, if you combine biased image data with biased text data, you can actually amplify those biases. You also run into serious privacy risks, where combining two anonymous data sets can suddenly make it possible to identify specific people. And then there's accountability. When these incredibly complex black box systems make a mistake, figuring out why it happened is a massive challenge.
So this all leaves us with one last, really provocative thought. We are just at the beginning of this journey to build an AI that perceives the world with the same richness that we do. But what happens when we get there? What happens when AI can not only understand the world like we do, but starts to see connections across sight and sound and language that are totally invisible to us? The discoveries that might unlock, well, they're as exciting as they are profound to think about.